Okay, now we're going to look at a hyperbola where the center is the origin, but it opens up and down instead of right and left. Again, this distance is a, therefore the vertices are 0, plus, and minus a. This is the focus, one of the foci. This is the other one. This distance is c, so that's the point 0, c. The foci are therefore 0, plus, and minus c. Again, c is the largest of the numbers, so the Pythagorean relation is c squared equals a squared plus b squared. In this case, the y square comes first before the x squared. The a and b, like we with ellipses, it doesn't matter which number is larger. That's not what we look at. All we need to look at for hyperbolas is it of the form y squared minus x squared or x squared minus y squared? That's what tells us what set of formulas to use. The last video we had an x squared minus y squared, so our formulas were a little different. All right, so here we have a y squared minus an x squared. That's what tells us we use these formulas and opens up and down. So what are the foci? Well, a squared, that's the number under y. A squared is 7. So a is the square root of 7. B squared is 9. So b is the square root of 9, which is 3. C is the square root of a squared plus b squared. So c is the square root of, when I square the square root of 7, we get 7. 3 squared is 9. And when 9 and 7 is 16. And the square root of 16 is 4. So now we can figure out the foci. The foci are 0, plus, and minus c. C is 4. So this is 0, plus, and minus 4. The vertices are 0, plus, and minus a. A is the square root of 7. So we get 0, comma, plus, and minus root 7. And the asymptotes, I forgot to write the equation of that. When x squared came first, we had b over a. When y squared comes first, it's a over b. So these are the equations for the asymptotes. So the equation for these two dotted lines, the asymptotes, are y equals plus and minus a over b, root 7 over 3, times x. So there's all the information we needed. Again, we could graph this. To graph this, I'll do it real quick. 0 plus, if this is the square root of 7, down here is minus root 7. 4 is up here a little further, and then you would graph these up root 7 over 3, so on and so forth, and you would end up with a graph that kind of looks, I don't know, something roughly like this. But that's the idea of solving these, working these problems with the equation of a hyperbola.